We're going to be doing part 2 of this problem, and then we'll be done with the whole entire problem. So let's get started. So in part 2, it says Captain Picard wants to reverse the electrons back to the Romulan spaceship. He orders Worf to fire a force field for 2 seconds that reflects the electrons back at their original path. If the magnitude of the electron's momentum is unchanged, calculate the vector force of the force field applied by Worf. In order to solve part B, we need to know the formula for the momentum principle, which I have written down right here. It is delta P, which is your change in momentum, is equivalent to your net force times your change in time. So we already have the initial velocity, we already have the momentum, but we don't really have these quantities yet, which is exactly what we're going to solve for. In order to fully understand this, we have to remember that we're reflecting the electrons back along the original path, so it's going to be going back the opposite way as it was originally. So this is going to be important when it becomes related to your delta P and your delta T quantities. So let's get started by actually explaining what does it mean to have a quantity called delta P? Like, what does that mean? It's a change in momentum. So delta P is your change, and that's also the same thing as saying it is your final momentum minus your initial momentum, right? So that's cool, but it doesn't really solve our problem yet. So we have to do a little bit more work. Remember that you want our final momentum to be the opposite of your initial momentum, right? So if that's the case, the opposite of our initial momentum is negative of the initial momentum. And then if we continue adding into this equation, we'll have your negative pi minus pi as well. So your delta P quantity is actually going to become negative 2 pi in this case. So if we continue on with this, we're going to substitute in the quantity that we just got for delta P back into our equation, and then we'll get negative 2 pi, so negative 2 pi equals F net times delta T. Okay, and our problem actually gives us delta T, so it is 2 seconds is the time that we're going to be firing the force field. So negative 2 pi equals F net times 2. Okay, so now what we need to do is we need to calculate our value for F net to be able to finish solving the problem. So we calculated the initial momentum. We've got the magnitude actually, so we actually need to get the vector quantity in this case. So if you remember from earlier, momentum equals gamma times mass times velocity. And we get our value from gamma in our VPython. And we also have your mass and initial velocity. So I'm going to actually switch over to that real quick. And we're going to calculate the initial momentum. And then we'll get our F net from there actually. So let's pull up VPython. So we have our initial momentum is gamma times m electron times your velocity. So let's try this. Times our initial velocity. So if you recall from earlier, We have VI up here in our program, and that has the actual vector quantity, and that's different from Vmag, which is the magnitude of the VI quantity. So using this, I should be able to print out momentum vector. Let me add a space real quick so we can actually see it better. Oh, low battery. Let's run it. And this is our momentum vector. You see right here is 6.513 times 10 to the negative 22, 4.0704 times 10 to the negative 22, and 0. Okay? So all we really need to do now is take this quantity and use it to plug into our formula that we had from before. If you remember, it was -2 times the initial momentum equals F net times 2, which is your change in time. So if we divide by 2 on both sides, we're going to get negative pi, so your negative momentum, equals F net, right? So all we need to do now is we just reverse the reverse the momentum, and we'll have our force that we need, and it'll be done. All we need to do is reverse our quantity for momentum. So we just multiply that quantity by -1. So let's print out our final answer, and we're going to be done with this problem. So final answer is negative momentum. Let's run it one more time, and we get our final answer to be negative 6.512 times 10 to the negative 22, negative 4.0704 times 10 to the negative 22, and 0. So that is the net force that needs to be applied in the electrons to get them to go back the way that they came. Alrighty, thanks for watching. That is it for this video. I have shown you guys a little Python, showed you guys some physics and how to apply the momentum principle to solve a problem. So I hope you enjoyed watching, and see you guys later.